Hello, everyone, and welcome back to the channel. As again, this is your host, Mike, and today we're going to be talking about IPv4 address basics and using the IP address and subnet mask to discover information about a network. So I've been doing a lot of training lately with CompTIA courseware, specifically with Network Plus and Security Plus. And one of the things that I've kind of discovered over the past year is not a lot of people understand IP addressing. And a lot of people don't potentially want to understand IP addressing. So, it's like, we got calculators for that. You can go find a website online. You could do this, you could do that. And the problem with that is they all kind of assume that you're doing this in a work or a personal context, as in you have a computer, you're connected to the internet, all that fun stuff. So the fun part comes in where you now have to go take an exam like Network Plus, Security Plus, Cisco CCNA, CCENT, whatever. Even Microsoft exams have networking on them. And you're now left to do this stuff in your head, right? And a scrap piece of paper. Okay? So whatever they give you when you go, take the exam, they give you like usually some type of like dry erase marker and like some type of laminated piece of paper to sketch some notes on, okay, while you're taking the exam. And so using the internet, using an IP calculator, it doesn't translate over to this space very well, obviously. And so you don't do as well on those questions on the exam. And I find that for me, those are the gimme type of exam. Those are the gimme type of exam questions because there's always a correct answer to them if you know how to do this stuff. Right? So it's not really subject to interpretation. Like sometimes on Microsoft exams, the answer is slanted towards the way that Microsoft would like you to answer it. Same thing with Cisco or what have you. But IP addressing, that's always a black and white type of topic. It's either true or it's not, right? It's true or it's false. It's rather, binary in that way. So what I'm going to do here is kind of take this from a beginning perspective and break down an IP address and show the different pieces of information you could discover about a network just by grabbing the IP address and a subnet mask from one of the devices that's plugged into that network. All right. So to begin here, if we look at an IP address, so the way I normally like to begin this, if I have enough time in the given class that I'm teaching, when I'm in front of, like a room full of students, and sometimes you don't always have the time for this, is I always like to kind of start it the way a computer looks at an IP address, right? Which is this, right? So that's how a computer looks at an IP address. It is a 32-bit value, right? So if you kind of counted all of this up, you would be seeing, if you counted all this up here, you would be seeing literally 32 bits of data, okay? So I'll take, I'm not going to count each one, just take my word for it. It's 32 there. Right? That's how a computer sees an IPv4 address. Right? Um, so ultimately, everything else we're going to do, that's how the computer breaks it down. It sees 32 bits of data. Okay. So everything that we need, we're working from that. Okay. So now what we do to make this easier to document, to type out, like if I tried to type all of this out here, okay, like, hey, Mike, write down that IP address, go hand enter that into a computer, I would probably mess that up like every day, twice on Sunday, right? So there's no way I would be able to get that right. And so what happens is the IP address is broken down into 8-bit parts that we call octets. Right? So an octet, OCTET is the spelling on that. So each 8-bit part is an octet. And so 32 bits total. If we break it down into 8-bit parts, we have 4 of them. 8 times 4 is 32. And then you separate each octet by a period or a dot, is normally what we say. right? Dot is the most common way of saying that, right? And then each 8-bit piece is converted into a decimal number, and this is where you get your dotted decimal notation from, right? For what an IP address normally looks like to the average person, right? So, I mean, if you take, most people that work on a computer could be able to identify this as an IP address. Maybe not know what it does, what it represents, but at least know that's what an IP address is. Okay, so that's what we see, but remember, this is what your computer is seeing up here. Okay, so the first step to kind of grasp when it comes to IP addressing is to be able to go from this to this. Right? And that is converting from uh, decimal to binary. Right? Now, in order to do that, you could obviously use a calculator. That's where, being in front of a computer kind of helps, but it does not help you when you're taking an exam. Right? So my whole point of this video here is to help people understand IP addressing in a way that will benefit them when they go take an exam, meaning that you've got some knowledge in your head and you're able to sketch out some stuff on paper to quickly figure some stuff out. Okay? Um, my my most recent video that I did a couple days ago um, kind of went over that as well, except it was doing decimal, hex, and binary conversions, right? So the biggest difference between that and this is the size of the amount of binary you're working with, okay? So here you're working with groups of 8 bits. You're working with octets. Okay? In my previous video with hex, you're working with blocks of 4 bits. One hex value equals 4 bits. Okay? That's how hex works. So here you're working with decimal numbers that are going to be converted over to 8 bits of data. Right? So 4 decimal numbers, 4 octets, 4 groups of 8 bits. So you get your 32 bits total. So go back to the previous slide here. You've got, again, 4 decimal numbers, and that converts to the matching 8 bits. Put those 4 groupings of 8 bits together, and you have your 32 bits, which is the IP address, okay? In the form that the computer is going to work with. Okay? Computer could care less about the decimal numbers. Those are just to make it easy for us to be able to type this stuff into the computer, document it on a piece of paper or in a spreadsheet or however you keep track of IP addresses. Okay? So first step is doing the conversion. Now with 8 bits, still the same concept of the bit all the way to the right is the least important one. So it's worth a value of 1. Okay? It's actually the how I get these values up here, they're actually based on possibilities. So the math on this is actually this first bit here is actually 2 to the 0, so which comes out at 1. And then you double it. So the next bit is worth a value of 2, 4, 8, 16, 32, 64, and 128. All right. So the bit all the way over here is worth 128, and the bit all the way over here is worth a value of 1. Okay, so binary growth. Now if you turn all of the bits on, so if I turn all of these bits on, the biggest decimal number you can make out of this is 255. All right, so an IP address in decimal that has a number higher than 255 is not legal. Okay? It's a fake IP address. You see them a lot in movies and TV shows. It's a way to show an IP address when you're, like you're showing a TV show, but without actually having to use an actual IP address, because I don't know, maybe they might get sued for something like that. Right? So the highest number you could possibly make by turning on all the bits is 255. So let's break down the IP address that was over here, right, in the first slide. So 192.168.5.78. Okay, so if you look here, you take the number 192. So in order to make that, I need to turn on the correct bits to equal 192. And for that, I just need the 128 bit and the 64 bit. So those both add up to 192. So you can see those two are turned on. All right, and then I just don't turn on the rest. All right, so that gives me 192. Now 168. 168, I need the 128 bit. I need the 32 bit. So 128 plus 32, that would give me 160. And then add in another 8. So I turn on the 8-bit, and that gives me 168. All right, and then the 16-bit, the 64-bit, 4, 2, and 1, I don't need those bits, so I leave them off. For the decimal number 5, to convert that to binary using, again, 8 bits, um, I need the 4-bit and I need the 1-bit. That adds up to 5. All right, and the rest I zero out. All right, so it's important to make sure you still have 8 bits here. So you zero the ones you don't use. So some different math calculators would actually wipe out the leading zeros. Okay, so if you ask it what 5 is in binary, it'll just say 101. So very important to not forget the leading zeros. You want an 8-bit answer. Okay, and then 78, we need the 64-bit, and we need the 8, the 4, and the 2-bit. All right, so 78, if we take 64 plus 8, that gives me 72, plus the 4 gives me 76, plus the 2 gives me 78. Right? So now if you want to go the opposite way, like if you have binary, you want to convert to decimal, literally just write the binary out and then just add the numbers that were turned on. Right? So, like you take from here the previous example, like, hey, I've got this binary right here, and I want to convert that to decimal. Well, you just superimpose that down over this handy dandy little chart here and add up the bits that are turned on. So literally like 64 plus 8 plus 4 plus 2. Right? Add that up and you get 78. Okay, so that's how we convert. Right? Now, an IP address in and of itself is not the most useful thing in the world. It needs to be combined with something called the subnet mask. So what the subnet mask does for us is it tells us in the IP address, so of those 32 bits, there's actually two pieces or two portions in the IP address. You have a network piece and you have a host piece. So one part identifies the network that a computer lives on, and the other defines the actual identifier for that computer. So hey, I'm looking for this network and I'm looking for this computer on that network. So in IPv4, those two pieces can vary in size. They're not always the same. Okay, so the overall address is always 32 bits, but the network portion and the host portion can be different sizes. Okay, so that's what the subnet mask tells you. So again, how a computer sees this is this would be a correct subnet mask, a correct format for a subnet mask. And basically what it is it's also a 32-bit value. Right? Now how it works is the subnet mask will always start with ones. So there'll be a bunch of consecutive ones, and then somewhere in there, there'll be a changeover from ones to zeros, and then it'll end with a whole bunch of zeros. Okay? So, and they're never intermixed, right? It's never going to go ones, then zeros, then back to ones, then back to zeros. A subnet mask always begins with ones, and it always ends with zeros. And what you're looking for is the line where the ones end and the zeros begin. And that tells me what's the host part and what's the network part, right? So the side of the IP address on the left, that's always going to be the network part. You just need to know how big it's going to be. So by looking at this, it tells me that, hey, it's that big. However many bits are in the subnet mask that are ones, that's how big the network portion is in bits. So this one happens to be 24 bits. And over here, the zeros, how many zeros there are, that tells me how big the host portion is. Okay, so in this case, it's 8 bits. So I know that my host portion is 8 bits for this particular IP address. Okay, so once I know that, the subnet mask is pretty much useless at that point. So the subnet mask is basically telling me the first 24 bits are network and the last 8 bits are host. Again, remember the IP address is 32 bits total. So if I just told you that the network portion is 24 bits, you should be able to figure out what the host portion is. So if the network portion is 24 bits and the IP address total is 32 bits, well, you just take 32 minus 24, and that gives you your host portion of 8 bits. Okay, so literally sometimes the answer could just be as simple as just basic math. 32 minus 24. My host portion is 8 bits, right? Now, most of what we're going to do in the next few slides here is working with that host portion, right? Now, like the IP address, the subnet mask, if you were going to tell me to write that out as a 32-bit value, I'd probably mess it up more often than not. Okay? So it gets converted over to decimal the same way that an IP address does. Okay? As in, you break it up into groups of 8 bits, and you convert each group of 8 bits, which remember we called that an octet. We converted that over to a decimal number. Okay, so if you see something with all ones, that converts over to 255. Because remember, all the bits are turned on. Remember the little example here before, if you turn on all of the bits. And if you have the whole octet zeros, that obviously converts to 0 as a decimal number. Right? So this is a very common subnet mask right here, where the first 3 octets, or the first 24 bits, are network for the IP address in question, right? And the last octet is host, right? Because the subnet mask is all zeros in that last or fourth octet, right? So normally, again, we do number the octets. We'll say this is the first octet, the second, the third, and then finally the fourth, right? Now, another way that the subnet mask can also be represented instead of as decimal numbers is through something that's called sitter or cider notation. Right? I say sitter, but a lot of people laugh at me, so I'm probably wrong, but that's the dialect from where I'm at. Being a New Englander. Anyway, so what that basically looks like is something like this, where you have the IP address, like over here, and then you would have a slash number, and then whatever that number is after it. So you'd have a forward slash, and then a number after it. So what does that signify? So basically what it's telling you is it's telling you in the IP address how many bits are network. That's all it's telling you. All right. So if I go look here, it's telling me that the first 24 bits are network. So it could sometimes be a quicker way of describing a subnet mask without having to having to write out 4 decimal numbers. All right. So this, if you're writing it out, that's sometimes quicker than that. And some interfaces in the computing world will want the subnet mask entered in this format. Right, so it's not all of them, but some. Like for instance, if you're making virtual networks in Azure, making an Azure VNet, it definitely wants the subnets in this format. Whereas if you're putting the IP address in manually in a Windows computer, um, it wants the subnet mask in this formation, the dotted decimal notation. Right? So either way, they're both signifying the same thing. So if you have this, what you could do is basically like each 255 is worth 8 bits, it's 8 ones. So again, you're just kind of, you're seeing again where that line is, where the ones end and the zeros begin. Right? And that line, right, like you see right here, that line's telling you the different pieces of the IP address and where they are. Right? So in this case, this part right here would be the host portion because the subnet mask has it all marked with zeros. Right? And then This piece right here would be the network portion. Again, because the subnet mask hasn't marked with all ones. Okay? So a 1 in the subnet mask means the corresponding bit in the IP address is network. A 0 in the subnet mask means the corresponding bit in the IP address is host. Okay? But again, don't overcomplicate it. Literally just use the mask to find where that line is. Right? And everything to the left of it is network, and everything to the right of it is host. So in a lot of cases, if you see the mask entered like this, you don't have to figure anything else out. You just know the first 24 bits, or in this case, the first 3 octets worth, if we're doing the dotted decimal notation, are network, and the last octet or the last 8 bits are host. Right? So, so that's basically how an IP address breaks down with its subnet mask. Okay, both in binary and in decimal. Right? So now let's, again, just re-emphasize here what that line does for me. So again, you got the ones, you got the zeros, and where that transition line is telling me the network bits versus the host bits. So like I said earlier, everything to the left of that line, those bits are network, and everything to the right of the line, those bits are host. Right? And again, if you're not familiar with how, let's say, routing works in a network or in the internet, for a computer, the IP address has the network part and the host part. It allows routers to find where everything is. Okay? So we need to know where the network is, where a packet is going to. And once the packet arrives at a router that's handling that network, that router will then figure out what host on that network the packet's going to. Right? So let's look at what we can now do with the IP address, because I mentioned, finding out some information about the network. So the biggest part of this is identifying the host portion. So once we know what the host portion is, the host portion has a bunch of patterns to it that allow me to figure things out about the network that I'm on. So if you sit down in front of a computer, maybe enter ipconfig or ifconfig if you're on a Linux box, and you look at the IP address and the mask, you can find out a bit about the network that that computer is plugged into. All right? So the first part is what network you're actually on. Okay, for every network that's out there, that network has an address itself. Okay, so that's the address that belongs to a network. Kind of like if I'm mailing you a letter, in the actual U.S. Postal Service mail, each town and each part of each city has a zip code assigned to it, right? So that zip code doesn't belong to me personally; it belongs to the town I live in, right? So everyone who lives in the same town, they all have the same zip code. So that kind of represents what a network address would be like, right? You're not sending something to a particular host. You're It's the network that all of those hosts kind of live on that are in the same area. So whether that's a company, whether that's your house, what have you, the network itself. So how do you identify if an IP address is a network address? Easy. The host portion is set to all zeros, right? So, and that's actually something you have to do quite often when you're in the networking world. If you're trying to figure something out, like, hey, what network is this computer plugged into? Well, what's the network address? It also lets you know if there's misconfigurations on the network, because two computers that are plugged into like the same switch, they both have to be on the same network. Let's assume you're not doing VLANs or anything like that. Two computers plugged into the same switch, that's the same Ethernet or hardware network, so they would have to both be on the same IP network as well. Okay, so that means in each of their IP addresses, the network address should be the same. Okay, so again, how do I find the network address that some computer is plugged into? You take the host portion and you zero it out. And I'll go through a whole bunch of examples doing that, so just bear with me for a moment here. Okay, So once I know the network, I can then find out the first usable IP address on that network. All right, so you take the host portion and set it to all zeros. And again, I'm talking binary now. You set it to all zeros with a 1 on the end. And that gives you the first usable IP address that you can assign to a device. Okay? That device might be your switch, it might be your router, it might be a printer, it might be your server, what have you. But again, you find the first usable IP address that you can assign to a device, right? Whether that device is a router, a server, whatever. Now, the last usable IP address, you take the host portion and set it to all ones with a 0 on the end. All right, so set it to all ones with a 0 on the end, and that gives you the last usable IP address. Now, again, why is that important? Gives me a range. Gives me how many addresses are available on a network. If I know the first one and I know the last one, I know what the range is. So I know potentially how big a network could be. Okay, so not every network is the same size. Okay, some networks are designed to have a lot of hosts on them. Some networks are designed to only have 2 hosts on them. That's the smallest you could possibly make. Okay, so there is a difference between that. Okay, there's definitely a big range in that. So finding the first usable IP address and the last usable IP address. Okay? Now, the way that I describe this, I'm not saying set it to 10 ones with a 0 on the end. I'm saying all ones because host portions vary in size. Sometimes your host portion is 3 bits. Sometimes your host portion is 23 bits, right? So these patterns, the way I'm describing them, will work with all host portions. Okay, because I'm never giving you an amount. I'm saying all. Okay, so all could be, all 8 bits, all 10 bits, all 4 bits. Just depends on how big the host portion is. Okay, so, and then the last pattern here is the broadcast. So the broadcast is a single IP address that every computer on the network will take in and respond to. So if I want to contact every computer on the network, it's not efficient to send out a packet for each computer to that computer's individual IP address. So instead, all computers are actually listening for a broadcast address as well. Okay. Um, so to do that, to find out what the broadcast address is, though you'll never use it yourself, the computer just kind of does that behind the scenes. You set the host portion to all ones. Okay? Again, in binary, set it to all ones. Okay, and that's your broadcast address. So these patterns here are going to be consistent throughout IPv4 addressing. Okay, for the network address, you set the host portion to all zeros. The first usable IP address I could assign to a device, set the host portion to all zeros with a 1 in the end. The last usable IP address, you set the host portion to all ones with a 0 on the end. And for the broadcast, you set the host portion to all ones. Okay? So now let's look at this, in a bit of detail here. Again, using the original IP address that I had all the way back on my first slide here. So if you're writing it down, this one here, 192.168.5.78. All right. So again, here's the binary, as 32 bits. Right? Because again, that's what the computer sees. Okay, and then the subnet mask allowed me to draw this line. Okay, so I just don't have the subnet mask shown on here, but basically remember that it was 24 bits. So I have the first 24 bits here, that was the network part, and then I have the 8 bits here, that's the host part, right? So just, draw a line. And now let's figure out the different pieces, right? Using those same patterns from the previous slide here, just with some numbers plugged into it now. So what I'm working with is I'm working with the host portion, right? So what did I say? To find the network address. So the address that belongs to the network, not each individual host, but the network itself. You set the host portion to all zeros. So that's what I did. I found the host portion. I saw it's 8 bits. So I set these 8 bits to all zeros. Right? So everything to the right of this red line. Right? So that's your network address. That's what a computer does, in all honesty. All right? That's how a computer figures out what network it's on in its own inner workings. It finds the host portion and zeroes it out. So for the first usable IP address, we take, again, the host portion, we set it to all zeros with a 1 on the end. All right? Just exactly like I described earlier. To get the last usable IP address, set it to all ones with a 0 on the end. And to get the broadcast, set the host portion to all ones. Okay? So that's where we're at in the grand scheme of things here. Okay? So now let's see a few. Let's see this with everything converted back to decimal now. Okay, so here I didn't have the octet boundaries drawn in here, right? So let's, we put some octet boundaries in here, and now we could convert these numbers back to decimal. Okay, so again, the first three pieces, 192, 168.5, that was the network part. And then the original host portion we were working with was 78, right? So again, if I zeroed out the host portion, that was 0, converted back to 0 decimal, because it's a whole octet's worth. If I set this to 1, all zeros with a 1 in the end, that converted into the decimal number 1. If I set this to all ones with a 0 on the end, that converted back to decimal number 254. And if I set it to all ones, 255. Again, if you don't remember, what was happening there, I'm just using this conversion chart from earlier. All right. So again, I'm working with 8 bits. So that's the purpose of drawing back in the octet boundaries, is so you're now working with 8-bit pieces so you can do the conversions. Convert from binary back to decimal. All right. So that gets me the different pieces. So here's the broadcast address in decimal, dotted decimal notation. Here's the first usable IP address and the last usable IP address. So that means in the last octet, it goes from 1 up to 254. So 1, 2, 3, 4, count it all the way up to 254. Now, one of the things you'll notice is notice the network part I don't change at all. Okay, so the network parts always stay the same. Okay, so it's always 192.168.5 in this case, because that's the network part of the IP address. Okay, so when we talk about manipulating the IP address, finding out things about it, we're just manipulating the host portion. All right, so I'm never, touching anything out here. Right, to find out the different facts. The network address, the first and last usable IP address, the broadcast, those all are found by manipulating the host portion. Right? That's basically how that works. Okay? So, a couple examples here. So let's say I have an address of 1082.151.96 slash 24. Okay, it's the same subnet mask as the previous one I was just going over. So that means the mask is 255, 255, 255.0. Right? So here's the IP address out in binary, and here's the subnet mask out in binary. Right? So, and again, if you wanted to convert, the decimal numbers over to binary, feel free to get the subnet mask. But realistically, the slash 24 told me everything I need. Told me in the IP address the first 24 bits or the first 3 octets. Because remember, an octet is 8 bits. So if I got 3 of them, I got 24 bits. So it tells me that slash 24, the first 24 bits are network. So that means the last 8 bits are host. Okay? So your network portion is over here, and your host portion is over here. And here's the line. Okay? Now the line happens to fall on an octet boundary. Sometimes that happens. Sometimes you're lucky, in that way. And sometimes you're not, in all honesty. So it is kind of the luck of the draw. Okay, so now let's find out the facts that go along with this IP address. So what's the network, what's the first, what's the last, what's the broadcast. So here it is. All right. So again, same IP address, 1082.151.96, right? That's exactly what I was working with. Okay. So here's what we have. So again, I used the mask to find the host portion, and now everything I'm going to manipulate is all in the host portion. So the network part, I'm not going to touch. This is going to stay the same across all the examples. Okay, you'll find I'm going to, when I get done with my examples, I've got 4 of them. When I get done with them, I'll sketch a few out just that I would do on a scrap piece of paper when I'm taking an exam. And you'll discover I only convert the octet where the network host line falls, where the subnet mask is. Right? So if I was doing this out on an exam, I would not convert these numbers over to binary. I would just do the last octet because that's where the mask is. Right? Um, that's where the host portion is, I guess I should say. All right. So again, to find the host portion, you did that. The mask gave us that from previous here. Right? So either I look at the decimal number or I look at the sitter notation or CIDR notation, and that tells me how big the network portion is, and then the rest of the IP address has to be the host portion. Right? So that's the last octet. So now I take the host portion, I zero it out, okay, and that gets me the network address. So again, no device is going to have the network address. The network is for the network. All of the devices that are plugged in. They all share the same network address. Um, so then you set the host portion to all zeros with a 1 in the end, like so. And that gets me the first usable IP address. Set the host portion to all ones with a 0 on the end, and that gets me the last usable IP address. And then set the host portion to all ones, and that gets me my broadcast. Okay, so set the binary, and then convert the number to decimal, and then trust that decimal number. So, sometimes like, oh yeah, 255, that's not in an IP address. Well, yeah, it can be. That is correct. It's a broadcast, but still, that's legit. Okay, so here would be the network address, 10.82.151.0. This would be the first usable IP address, the last usable IP address, and the broadcast. All right. So next example. So in this case, I'm going into the 4th octet. So the network host line is not on an octet boundary in this case. So notice the /28 or the fact that my subnet mask is ends with 240. So that converts into, if you were to draw out the subnet mask, I mean, literally it's 28 ones and 4 zeros. All right? So that's a /28 or 255, 255, 255.240. All right? So this last octet here, yeah, that's 240. 11110000. Okay. So now, same thing. You find the line where the ones end and the zeros begin, and that's your mask. So everything to the left is the network portion, right, in the IP address, and then everything to the right is the host portion. So the first 28 bits are network, and then bit 29, 30, 31, and 32 are host. Okay? So now that we know where our host portion is, it's the last 4 bits of the IP address, we can then do our patterns. So again, here's the original IP address, okay, in binary and in decimal, with the line drawn. And to do the network address, I take the host portion and I zero it out and convert, carry down, or remember, we're not changing the network bits. So those network bits stay the same. Okay, so I'm only working with the host portion, which in this case happens to be 4 bits. So I'm leaving the network bits alone. Because remember, we started with this up here, right? So when we converted that on the fourth octet, that's what we got, right? It's 210 converts to 11010010. Okay. So remember, the first part of the fourth octet is network, so that does not change, just like the rest of this does not change. Okay, so I carry those bits down, or I leave them as is, and then I'm just manipulating the host portion, which in this case is the last 4 bits. So I'm setting them all to zeros to make the network address. And now when I convert the whole fourth octet back to decimal, that's the number I get. Okay? So now set the host portion to all zeros with a 1 on the end. So again, in this case, it's 3 zeros with a 1 on the end. And then consider the network bits at the beginning of the fourth octet, the 1101. Look at that now. So I got the bits I changed right here. I got the bits that were the original part of the original network. Those stay the same. Put it back all together as an octet, right, and convert it to decimal, and that's the number you get. Okay, so that's where that 209 is coming from. It's not just these 4 bits right here. It's the whole fourth octet. Right? So part of the fourth octet, the beginning part is network, okay, because that's what our mask told us from earlier. And then the last part is the host portion, which is what we're manipulating here, what we're changing. Okay. So now to get the last usable IP address, I set the host portion to all ones with a 0 on the end. I leave the beginning part of the fourth octet the same. Okay. And then look at the whole thing now and convert that back to decimal, and that gets you 222. And then lastly, set the host portion to all ones and leave the network part of the fourth octet alone. And then look, look at the whole 8 bits, convert that back to decimal, and you get 223. Okay. So the network is 192.168.32.208. The first usable is 192.168.32.209. The last is 32.222, and the broadcast 32.223. All right. So now let's do an example where we are working in the third octet, okay, which will happen sometimes. So in this case, notice my mask is /16, and notice my mask in dotted decimal notation is 255.255.0.0. Okay? So for this, if I draw this out as the subnet mask, literally it's 16 ones, that's what the mask looks like, and 16 zeros. Okay? So that will be this if you converted it over to decimal, or this in the dotted in the sitter or cider notation. Okay? So again, that /16 means the first 16 bits are network. Okay? So if you're looking at it as a mask, you would set the first 16 bits in the mask to all ones and set the rest of the bits to zeros. Okay? So that tells me that the first 2 octets are network and the last 2 octets are host. Okay? And that's what my red line here is signifying. Oops, didn't mean to move that. That's what my red line is signifying. Okay? So now let's kind of do our patterns, right? So the network address, again, my host portion is 16 bits worth. All right, so what did I say to do for a network address? Set all of the host bits to 0. You zero out the host portion, right? I didn't say the fourth octet, I didn't say the third octet, I said all. So in this case, my host portion spans more than 1 octet. So I zero it all out. And now when I convert that over to decimal, I get 0.0. Okay? Now, to get the first usable, I set the host portion to all zeros with a 1 on the end. All right? All zeros with a 1 on the end. Notice I didn't say all in the third octet, all in the fourth octet. I said all, the whole host portion. So in this case, the host portion is 16 bits. So it's literally 15 zeros with a 1 on the end. Now, pay attention to that octet boundary though, because you're going to need that when you convert it back to decimal. So now I take the third octet, convert that to decimal. I take the fourth octet, convert that to decimal. All right. So again, using the same chart that I kind of began at the beginning of this video, right? This chart right here. All right. Um, so anyway, so where was I? Here. Okay. Um, Okay, so now the last usable IP address. Set your host portion to all ones with a 0 on the end. Right? Again, this time with this example, it spans the octet boundary, right? So the whole third octet is all ones, and the fourth octet is ones with a 0. So that gives me total the whole host portion. I've got 15 ones with a 0 on the end. Okay? Now, when you convert back to decimal, pay attention to the octet boundary, right? So the third octet, convert that back to decimal, and the fourth octet, convert that back to decimal. So when your host portion spans more than one octet, you really want to pay attention to that octet, to that octet boundary, right? And then finally, the broadcast, we're setting the host portion to be all ones. Okay? So again, that's 16 ones. That's how big our host portion is. So now pay attention, third octet, convert that back to decimal, and fourth octet, convert that back to decimal. All right? And that gives us our network address, first usable IP address, last usable IP address, and broadcast address. Okay, so now one thing I do want to note, if you're incrementing these, like if you're going to start handing out IP addresses for devices that would be on this network, how you increment it in decimal. If the first usable IP address is 0.1, the next usable IP address would be 0.2, and then 0.3, and then 0.4, and so on. Now, what if you get up to 0.255? What do you increment to next? You increment the third octet to 1, and then this would drop back down to 0. All right, so basically, you're making the whole host portion be a mixture of zeros and ones. Okay? Can't be all zeros because that would be the network address. Can't be all ones because that would be the broadcast. So a usable IP address, the host portion is always a mixture of zeros and ones. Okay? So then it'd go 1.0, then 1.1, 1.2, all the way up to 1.255, and then it would increment to 2.0. All right. And then 2.1, 2.2, 2.3, up to 2.255, and then it would go over to 3.0. So that's how you'd increment them, all the way up to 255.254. All right. So again, let me just put that back to what the binary actually looks like, for example here, and that's in fact the first usable IP address. Okay. And again, if that, some people are like, well, wait a minute, just go back to that part of the video and just watch how I increment it through. Okay. So the last usable and the broadcast. Okay. So last example here. This one I'm using part of the third octet and the whole fourth octet for the host portion. And the network portion would be the first two octets and part of the third octet. Okay? So the mask in CIDR or CIDR notation is /19, or in dotted decimal notation is 255.255.224.0. Okay. So now, if I converted this to binary, this is what I get. Okay, so there's the first two octets. There's the 255.255. Here's the 240, and then here's the 0. And again, notice it gives me the same look, right? You've got a whole bunch of ones, consecutive, and then that stops, and then you've got a whole bunch of zeros. So what you're looking at is the line here where the ones end and the zeros begin. So in this case, it happens between the 19th and the 20th bit, right? So that's where I draw my line. So now what it means in the IP address, it means the first 3 bits in the third octet are network bits. They're part of the network portion. Okay, so this whole thing here is the network portion. That means you're not going to change them. Okay, we're not going to manipulate them. So the host portion is the last 5 bits in the third octet and all of the bits in the fourth octet. That's the host portion. All right, so that means we're going to manipulate that side. So the last 5 bits in the third octet I'm going to be changing, and the first 3 bits I'm going to leave alone. So that 100 is going to stay the same. Right? So now let's go look at the patterns for that. So again, look at the third octet. I'm leaving, so to find the network address, I'm leaving the first 3 bits, 100, because they're not part of the host portion. They're the network portion. You leave that alone. And so I'm taking the host portion, which is the last 5 bits in the third, and all of the bits in the fourth octet, and I'm setting them to zeros. So now, convert it back to decimal. I look at the whole third octet, the part I changed and the part I left alone. I left the network bits alone, and I changed the host bits. Now take the whole third octet, convert it back to decimal, and you get 128. Why? Because if you look at the whole thing, the only bit that's turned on is this bit right here, and that's the 128 bit. Right? And then the fourth octet, that should be pretty simple there. It's all zeros, so that converts into decimal number 0. All right. So the first usable IP address, I'm leaving the network bits alone, and I'm setting the whole host portion to all zeros with a 1 on the end. All right. Then pay attention to the octet boundaries because we got to convert it back to decimal. Here's your whole third octet, the bits I left alone, the 100, and then the rest of the bits I changed. Convert that back to decimal. And then your fourth octet, convert that to decimal. All right. So for the last usable IP address, 100, again, I'm leaving those network bits alone, and I'm setting the host portion to all ones with a 0 on the end. All right. Um, and then converting back to decimal, I look at my whole third octet, convert that back, that's 159. And then, and when I say 159, I'm literally converting that. Okay, that's the whole third octet, the bits I changed and the bits I left alone. Okay, so the network bits and the host bits that I changed. Okay, network bits I left alone, host bits I changed. And then the fourth octet right here. Fourth octet right here. All right, that converts to 254. And then finally the broadcast, setting the host portion to all ones. And again, converting back to decimal. Look at your whole third octet, convert that to decimal. And then look at your whole fourth octet, convert that back to decimal. All right? So that's where we're at with that. Okay. So now that I say that, that's that's where we're at with that. Let me switch over to just kind of a blank canvas here. And if you're wondering what I'm using, I'm just using Microsoft Paint because this is now stuff I might sketch out if I were taking an exam, right? So all of those pretty charts I just made, you can't take those into an exam with you, right? Or pretty PowerPoint or whatever. I think it's pretty basic PowerPoint. But so let's do a couple of examples, like kind of like you're sketching on the paper that they give you when you're taking an exam, right? So let's say I'm working with an address. Let's say I'm doing, let's say address 10.45.107.145, and the mask, I'll just do the CIDR mask. I'll do /27, all right? Which if you were writing it out, it would have been 255.255. Actually, I'll just write it out. 255, 255, 255 dot, and let's see, that's 3, 224. That's what it would have been. Or what it is, I should say, not what it would have been. Okay. So also, probably a good idea to sketch out your, that's kind of a crummy one there. IP calculator here. 32, 64, and 128. Okay, I apologize. This doesn't look nice and fancy. Literally, the whole point is this is what I would sketch out on maybe a scratch piece of paper when I'm taking an actual like exam here. Okay, so now we want to find the same things, right? Okay, so in this case, the subnet mask is falling in the fourth octet. And you'll find that happens on most of your computer exams. Network Plus, Security Plus, CCNA, Microsoft networking exams, they do a lot of fourth octet stuff. So if you're going to learn the way that happens the most, this is probably what you want to pay attention to. Okay? So what I'll do is I'll normally just kind of draw out the first three octets because they're all going to be networks and nothing changes in them, right? And then I'll convert out 145 into binary, that fourth octet, okay? So that's 145. So we're going to turn on the 128 bit. We don't need the 64 or the 32. We need the 16. So 128, 138, 144. I don't need that, that. I need that. Okay, so that should be 145 if my math is correct. All right. Feel free to correct me in comments if I'm not. So that's the fourth octet. All right, like so. Now, let me change my pen over to red here. We're going to draw in the subnet mask. Okay, so slash 27, this, so again, this is the first 8 bits, the next 8 bits, the next 8 bits. So the first 3 octets gets me up to bit 24. So this would be bit 25, bit 26, bit 27. Okay, so I'm going to draw the mask right there. So everything over here is network and everything over here is host. Okay, so now I'm going to do my patterns, right? So I'm going to take the host portion and let's say I want to figure out the network address, right? I'm going to set the host portion to all zeros. Zero out the host portion. All right, carry down the network bits in that fourth octet that don't change, right? So carry those down. And now I have a whole 8-bit value in that fourth octet. So the network bits that were there and the host bits that I changed because I want to figure out the network address. So in this case, the network address, so again, this is the network address, would be 10.45.107. If you look at the fourth octet, the only bit that's turned on is the 128 bit. So that would be dot 128. All right. So now we want the first usable IP address. Let's maybe draw that one in, I don't know, blue. All right. So I'll carry down the network bits because those are not going to change. Oh, this would be the first usable address. And then set the host portion to all zeros with a 1 on the end. All right, and then let's convert that, the whole octet now, okay, the network part that stayed the same and the part that I just changed, let's convert all of that to decimal. So all of it, the whole octet, 45.107. Again, the only bit that changed there from the previous was I just turned on the 1 bit. So that would just be 109, no, 129. There we go. Okay, so that's your first usable address. Let's do the last usable address. Let's maybe, sorry about that. Let's go change to, I know, green. Carry down the network bits, and then set my host portion here to all ones with a 0 on the end. And again, convert it back to decimal now. Remember looking at the beginning part of that fourth octet, and that would be 10.45.107 dot, and what would that turn into? So let's see. So I got 128 plus, let's see, 64, 32, 16. So 128 plus 16, 128, 138, 144 plus the 8, that would be 152, 156, 157. 157, that sound right for everybody? For everybody, like this is a live class. I'm, talking to myself here. Let's see. I'm not the best at math. I apologize. Um, so let me just double check this without having to do math out by hand on a calculator. Let's see. So 128. So I turn on the 128 bit, the 16, the 8, the 4, and the 2. Yeah, 158. All right. I just didn't trust myself. So let's where'd my mouse thing go? Okay, there we go. So that would be 158. Okay. And then the broadcast. Let's pick a color for the broadcast. Maybe we'll make that, I don't know, magenta. That looks cool. So that would be the broadcast. So we're going to carry down the network bits because, again, those are not changing. And then we'll set the host portion to all ones. And then convert that whole fourth octet now, not just the last 5 bits, but the whole thing. 107, and that should be, if the previous was 158, this should be 159. All right. So that would be our numbers. Okay, just sketched out, let's say on a, on a piece of paper. Right? Highly accurate there. Right? Sketching out on some scrap paper they give you in an exam. All right. So let's do one more, and then we'll call it a video here. How's that sound? So let's wipe that out, and we'll do one more. So the last one here. So let's first of all find where my mouse is. We'll kind of draw out again our calculator. I might not use it a lot, but in a lot of cases, it's a visual item. So, if I want to see, what the third bit is worth. Oh, it's worth 32. What's the sixth bit worth? Oh, it's a value of 4. Right? So it's a visual thing. I usually like to have it sketched out. I don't necessarily use it as much as I probably should, but it's a visual thing. Okay, so then the address. Let's work with, and again, I'm in all honesty, I'm just making these up. I do this a lot on a whiteboard in a classroom, when I have live students, and they're always like, hey, can you give us, examples? And it's like, well, just take some numbers and just write them out. As long as you don't go higher than 255 in each octet, you can totally just write some numbers out. I'm purposely, though, using 10, 172.16, 192, 168, because those are all private address ranges. That way I'm not mistakenly using somebody's public stuff. But anyway, so, okay, so we got that. And a slash 29, that would be, let's see. Slash 29, you're literally turning on the first 5. So 128 and 64 is 192 plus 32 is 224, 240, 248. So there would be the mask in decimal notation. Right? I really like it though when it's like this. It's just a lot easier to work with. Right? So now write out the address, and then I'll convert the fourth octet over to binary because that's where the line between network and host is. So work in binary. So I need the 64-bit. I need the 8-bit. That would give me 64. That would give me 72. I don't need the 4-bit. I need the 2 and the 1. That'll get me 75. Okay. So now the line is going to be, let me change my pen back to red here. The line is going to be after the 29th bit. So this is bit 25, 26, 27, 28, 29. So the line's right there. Okay, so let me go ahead and draw that in. So the line's right there. So that means in this case, the first 29 bits over here, that's your network portion. And over here, the last 3 bits, that's your host portion. All right, pretty small host portion. Not the smallest though. You can actually have a host portion that's 2 bits. That's the smallest you can have. So the mask on that would be /30, or if you're doing decimal, this one here would be 252. Right? Okay, so now I want the broadcast. So for the broadcast, I'm sorry, the broadcast, I want the network. I want the network address. So I'm going to carry down the bits that are currently there, right? Because these are network bits, so you don't change them. And then I'm going to zero out the host portion. And so then pay attention to that octet boundary now. And then we convert this back to decimal. And my network address would be 192.168.23 dot. And then what's that going to convert into? We got 64 and 8. So that would be 72. Okay, so let's see. So now we want the first usable. So let me change my pen over to blue. And we're going to do the first usable as. So we're going to carry down the network part because we're not changing that. And for the first usable, I take the host portion, I set it to all zeros with a 1 on the end. So, and then we're going to look at the whole thing to convert it back to decimal. And that would be 192.168.23, the dot, and that would be 73. Right? Because again, the only difference between this and this was you just turned on the 1 bit. So if this was 72, that's got to be 73. So sometimes you don't have to do a lot of math, which that's definitely a favor for me. Okay, next one here. Let's do last. So we're going to, again, carry down the network. And then let's carry this down too. And then set the host portion to, remember doing the last usable address, we're going to set the host portion to all ones with a 0 on the end. And then take the whole thing and convert that to decimal. And that would be 192.168.23. And then the last octet, let's see, what did we turn on? So let's say we got 72 plus 4, that's 76, 77, I got 78. So 64 plus 8 plus 4 plus 2. All right? So 78 is what I think that is. And then the broadcast. Oh, my bad. Change my pen again so they stand out. Broadcast. So carry down the network, and then for the host portion, you're setting it to all ones. And then convert the whole thing, the network bits that stayed the same, and the host portion that I changed over to all ones, and that would be 79. All right? So that would be the facts that I could figure out about an IP address. So again, kind of the whole portion here, given an IP address with a mask and either CIDR notation or dotted decimal notation, and the facts you can figure out. What network it's on, the first usable address on that network, the last usable address, and the broadcast. Okay. So that was, I think I did 6 different examples there. So the last two were on purpose sketching out in Notepad because I'm trying to demonstrate how you might do this on a scrap piece of paper that you have when you're taking an exam. That's kind of the whole point of this, is not to do fancy spreadsheets or use an IP address calculator that's installed in your computer. Neither of those things are available to you when you go take an exam that has IP addressing in it. So when you take an exam that has IP addressing in it, it's you, the testing app you're using on their testing computer, a scrap piece of paper, and some type of writing device. Usually it's like a dry erase marker or something. Right? So this is how we could figure out the facts about an IP address. Right? And everything we did here is kind of a precursor to ultimately subnetting, if you will. So believe it or not, this was not subnetting. This is not taking one bigger network and making a lot of smaller networks out of it. This is just finding the facts of a single network. Okay? So any questions, comments, anything like that, please put them down in the chat. If you appreciated this, please consider liking and subscribing. Greatly help me out, greatly help the growth of my channel, which I appreciate both. So have a good one, everybody, and we will see you in the next video.